Today we're going to be learning about the families of the periodic table. In the periodic table, a period is represented by a row. The number of electron shells, or energy orbitals, an atom has determines what period it belongs to. There are 7 periods on the periodic table, each shown here in a different color. Remember from the Bohr-Rutherford lab that all elements in period 2 have 2 electron orbitals. In the periodic table, a group is represented by a vertical column. The number of electrons in the outermost shell determines the group. In the periodic table, there are 10 groups, shown here in different colors. When we completed our lab, elements with the same number of valence electrons ended up in the same groups or families. The outermost shell of an atom is called the valence shell, and the electrons that are located on the shell are called valence electrons. Note that all of the elements in group 1 have only one valence electron. The number of valence electrons determine an element's properties. Elements with the same number of valence electrons have similar properties and are in the same family. The periodic table is arranged into 9 families. The alkali metals, which are the first group on the periodic table, excluding hydrogen. The next family is the alkaline earth metals, which are located in the second group of the periodic table. After the alkaline earth metals comes the transition metals. This is the large section in the middle of the periodic table. After the transition metals comes the basic metals, which are located below the stair step and include all of the elements in light blue. The stair step divides the metals and the nonmetals and starts at boron, which is a semimetal or a metalloid. The metalloids are the mustard-colored elements and have the properties of both metals and nonmetals. The elements in green located above the stair step are the nonmetals. Hydrogen is a nonmetal. The elements in group 7A are the halogens, and the elements in group 8A are the noble gases. The elements that are below the periodic table are the inner transition metals. Each family has its own unique properties, which are determined by the number of valence electrons. The number of valence electrons that an element has plays a key part in how reactive or unreactive an element is. Metals, or the families to the left of the stair step, including the alkali metals, the alkaline earth metals, the transition metals, the basic metals, which are located under the stair step, and the inner transition metals, are all very reactive. Nonmetals are the families to the right of the stair step, including the nonmetals, located above the stair step, the halogens, and the noble gases, are very unreactive, especially when compared to metals. Metalloids, which are located on the stair step, can be reactive or unreactive depending on which element it is reacting with. For example, boron behaves as a nonmetal when reacting with sodium, but it acts as a metal when reacting with fluorine. Valence electrons are important in determining how an element will bond with another element, but we will get into that in the next section.